Socratic math tutor here. So let's assume we're given a cubic polynomial. For the sake of example, I'm choosing 8x cubed minus 26x squared plus 31x minus 15. And let's also assume that we have a degree 1 factor. So in this case, we're going to use 2x minus 3, which turns out to be a factor of this cubic polynomial. And there's a few different ways you might get a factor like this. You might actually work it out yourself. There's a few different methods for that. It might also be given in the question. In any event, we're going to assume that we're at this stage where we have a cubic, we have a degree 1 factor, and now we want to find the quotient, which should be a quadratic. So we should get a quadratic popping out here. And the question is, what is that quadratic? Well, it turns out there's a shortcut method for finding it. So I'm going to start off by showing you how the method works, and then right at the end, we'll actually derive the formula that the triangle and balloon method actually depends on. So here's how it works. First, we compute this quotient, and this becomes our coefficient of x squared. So 8 over 2 is 4, therefore I write 4x squared. Then we compute this quotient, and that becomes our constant term. So negative 15 over negative 3 is positive 5. So I'll write plus 5 out here. And then the only question is, what is the coefficient of our x term? So in other words, what needs to go here to make this equation true? Well, it turns out there's a really easy method for finding this number, which I call the triangle and balloon method. Now, if you've never heard of this method, don't feel too bad about that. It's something I've come up with, and I really do think it's the fastest method out there. So first, we need to do something really strange. So we're going to draw a triangle, and then we're going to put a balloon off to the side, and then we're going to populate this with 4 numbers. So A, B, C, and D. And the idea here is that this very strange notation just means A over B. So it's the quotient of these 2 numbers. Then we extend this out, we put a minus, and then the product of these 2 numbers goes here. So C times D. So A, B, C, D like this equals A minus CD over B. Looks totally strange. You probably have no idea what I'm doing right now. But actually this formula answers our question. So how does it work? Well, let's put a triangle here, get these numbers in the triangle, extend it out, capture that number, and then we just use this formula. And I want to emphasize here that A, B, C, and D are just the numbers, so we're kind of ignoring the x's. So for example, A is negative 26, B equals 2, C equals negative 3, and D equals 4. And the way to remember that C times D goes in the numerator is to just think of C as kind of holding the balloon, right? Because our balloon kind of attaches where C is. So just imagine C is holding the balloon, but C is not heavy enough. So it kind of gets pulled up into the sky with D. And that's why C times D is up the top in the numerator. So let's try solving the problem without the formula in front of us, like in a real test situation. And we'll just keep in mind that the C is pulled up by the balloon and joins D in the sky. So it's this number divided by that number. Then we extend out the fraction line, we put a minus, and then the negative 3 is pulled into the sky and joins 4 in the numerator. So negative 12 goes into the numerator. And now we just work this out. So negative 12 is positive 12. So we have negative 26 plus 12. And that gives us negative 14 in the numerator. And this simplifies to negative 7. So the coefficient of x that we need is negative 7. It's really just that easy. So you draw a triangle, then you put this balloon surrounding the coefficient of x squared in your answer, and then you just work this out. So that's the technique. You can use it without really understanding it. But if you're the kind of person who likes to know why things work, then stick around, because we're about to answer exactly that question. So we're trying to find ax cubed plus bx squared plus cx plus d divided by ex plus f. Okay, obviously this e does not mean Euler's number in this context. It's just a coefficient. And we're assuming that the denominator divides the numerator, meaning that the result is a polynomial. So we'll call that ax squared plus bx plus c, with capital letters over here. So the question is, what are capital A, B, and C in terms of these coefficients? Well, we can knock out the denominator by just multiplying both sides by this. So we get this line here, the cubic goes on the left. On the right, we get a product of two expressions. And we want to expand this out, so there's a few different ways of doing that. My preferred approach is to just use a grid. So we'll put the E and the F here. We'll put the A, B, and C up here. And then we just start multiplying things. So this is a general method for multiplying out polynomials. So EA goes here, EB, EC, and then FA, FB, and FC. This is our constant term. This is our coefficient of x to the 1. This is our coefficient of x to the 2. And this is our coefficient of x cubed. So that's one possible way of multiplying out these polynomials. Go ahead and use your own approach if you prefer that. So I'm going to write EAX cubed plus EB plus FA x squared plus EC plus FB times x plus FC, which is our constant term. And this equals our original numerator. So now we can equate coefficients. The coefficient of x cubed on the left is A, and on the right it's E capital A. So we get this equation, and then we can do the same thing for the remainder of the terms. So this probably looks a bit intimidating, there's quite a lot going on, but it's honestly not that complicated. So we're trying to find capital A, so let's rearrange this to get capital A by itself, and on the other side we get A over E. So that explains why this quotient equals capital A. In a similar way, we can go over here, rearrange to get capital C by itself, we get D over F on the right hand side, and so that explains why this quotient equals capital C. So all that's left now is to find capital B, and there's really two ways of going about it, because we have a capital B here, and we also have a mention of capital B here. So either one of these equations can get us the answer. For the triangle and balloon method that I showed you guys in this video, we should focus on this particular equation. So let's rearrange it to get EB by itself. We get B minus FA on the left, EB on the right, and that tells us that capital B equals B minus FA over E. And this is that formula we saw before, which we were denoting B, E, and F in a triangle like that, with a balloon attached for capital A. And so this gives us the triangle and balloon from earlier. So there's the triangle, move that out, there's the balloon. And so the whole reason we need this balloon is really because we have a capital letter in our formula for capital B. So that means part of the answer needs to feed back and give us the rest of the answer. And by the way, if you were to use this formula to get capital B instead of this one, well, you'd still get a valid formula. So you get lowercase c minus lowercase e times capital C over F. So this time the balloon is surrounding the capital C, this part, instead of the capital A. But this is also a valid formula, and this is also a good way of getting capital B. And if you're wondering why this formula always gives the same answer as this formula, since after all these are both formulae for capital B, well, the reason is because we're assuming that EX plus F is actually a factor of the numerator. If it wasn't a factor, we'd actually get two different answers from here, and so no matter what B we use, the quadratic we get out the end is going to be wrong, because after all, the answer is simply not a quadratic. So that's it from me for today. If you enjoyed the video, don't forget to subscribe. That way you can get more tips and tricks as I create them, and it'll also help motivate me to continue creating these videos. Alright, it's goodbye from me for now.